Okay, here we have some given position versus time graphs. So we have, position here on the vertical and time on the horizontal, or um, time on the independent and position on the dependent axes. And we're given these plots of position versus time, and we are asked to make corresponding plots of velocity versus time. So I have these graphs set up here for v versus t, right? And actually, this is vx, v sub x versus time, because this is giving us position in the x direction, right? The x coordinate. So this would be then velocity in the x direction. I couldn't tell if this were two-dimensional motion. I couldn't tell anything about the y direction from these x position versus time plots, but we're still dealing with one-dimensional motion anyway. So we have these velocity versus time plots that we'll make from these position versus time plots. And remember that the slope of the position versus time is the velocity, right? So I have, the change in position with time. And we have, delta x over delta t, rise over run there. That is the velocity. So the slope at every point translates to the value of the velocity. So in this first one, I have a constant slope, right? The rise over run remains constant in each case. So a constant slope would then translate to a constant value, right? A constant slope in my position versus time should translate to a constant value in my velocity versus time, right? If the slope's the same everywhere, then the slope on the position versus time is the same everywhere, then the value of the velocity versus time will be the same everywhere. So this is asking for just qualitative analysis here. So we can look at things just like is it a constant slope? Is it positive? Is it negative? Or is it zero? Look at those things there. We look at the first one, A. This is a positive slope, right? So then that's going to positive constant slope translates to a positive constant value, something like this. Okay, so that would be the corresponding velocity versus time graph. If the slope of this is 3, like rise 3 over 1, then the value of this is 3, if I did want to put numbers to it. And then we go along to B over here, and we have the slope is constant, right? The slope isn't changing, and now it's a very particular value of the slope, and it's 0, right? So we have no slope. Well, we have a slope of 0 here, and so that would mean that the value of the velocity versus time is 0. So this one would, very specifically need to be right here. Even qualitatively, it needs to be at 0, right? I can put a number on it, but even in a qualitative analysis, it would need to be at 0 here, because clearly a 0 slope is going to correspond to a 0 value. And then the last one, I come over here, and in part C, we look and we have a negative slope, right? And it's a constant slope. So we have a negative constant slope here, would translate to a negative constant value in the velocity versus time plot. So something like this. Right? So I should extend this down. And, this is like a negative velocity down here. And so I would have a negative constant velocity. So basically, my rate of change of position is the same, constant, and it's negative, right? So then I have a negative constant velocity there. So there's some translating position versus time to velocity versus time, which we always have to do in one-dimensional motion. If I wanted to have a y, if I had a y position here, then I would need another plot here, for Vy versus time, right? And I would have to have a whole separate, position versus time plot for that. So we really graph just one-dimensional motion. We graph like x versus time on one graph, y versus time on a different graph, etc. Velocity in the x direction versus time on a graph, velocity in the y direction versus time on a separate graph.